बिस्मिल्लाहिर्रहमानिर्रहीम। तो आज का जो हमारा क्लास है दैट इज़ अबाउट द इलेक्ट्रॉनिक ट्रांजिशंस। जिसे हमने पढ़ा था कि यू विजिबल स्पेक्ट्रोस्कोपी में when the molecules or when the solution it absorbs the ultraviolet visible radiations, it actually results in the excitation of electrons from one level to the next. So now what types of electronic excitations occur here? So that we'll deal today. So the electronic transitions which occur in the usable spectroscopy. So electronic transitions means when a material absorbs the energy, so it results in the electron transition. So now what type of transitions are there? There are many types of transitions. For example, अगर हमारे पास एक molecule होगा, this is a molecule. This is a hydrocarbon molecule, a hypothetical molecule. But a hypothetical molecule basically it's a molecule. इस तरह का एक molecule हमारे पास है. अब इस मॉलिक्यूल में ये सारे बॉन्ड्स जो है these are sigma bonds. Fine. So these all bonds are sigma bonds. So it has sigma bonds. इसका मतलब है जो electrons इसमें present होंगे there will be sigma electrons. So if this molecule absorbs the radiations, obviously because sigma bonds are there, you have to excite the sigma bonds. तो electrons in the sigma bonds will get excited. तो हम कह सकते हैं कि there are sigma bonds, and we know that in each molecular orbital is a bonding molecular orbital. There's an anti-bonding present. So if this molecule absorbs the energy, the electrons from the bonding orbital, they will get excited the anti-bonding. So we can see in this type of molecule, you will have a sigma that is bonding to sigma anti-bonding transition. Obviously, since it's a strong bond, so it will be in the ultraviolet region. So you see it has a sigma to sigma star. This is anti-bonding orbital. So this transition is possible. Now, if you have another type of molecule, example, if you have this type of molecule, an ethene type of molecule. इस molecule में यहाँ ये जो पाई बॉन्ड सिग्मा बॉन्ड एंड पाई बॉन्ड जो डबल बॉन्ड है, अब ये सारे सिग्मा बॉन्ड्स हैं. These are sigma bonds, all sigma bonds. Now there are two types of electrons. We have sigma electrons and we have pi electrons. जो किस पाई बॉन्ड में है. Well, that means there will be two types of transitions. There can be sigma to sigma star transition, and there can be pi to pi star transition. So there can be two types of transitions, sigma to sigma star and sigma to pi transitions. So a sigma to sigma star, sigma to pi transitions. Sorry, pi to pi star transitions. ठीक. अब यहाँ तो डायरेक्टली हम सोच सकते हैं आराम से it's a pi bond, it's a weaker bond. That means it is easy to transit, it's easy to excite the electrons from pi bonding to pi anti-bonding. So there will be low energetic. That compared to this sigma, it is high energetic. Okay. So we'll take third example, then we'll move to our actual, this is diagram. Now if you have this type of molecule, जो हमने last class में भी example दी थी, this is a ketone molecule. So this is a sigma bond, this is a pi bond, and then we have lone pair. So these are also sigma bonds. Fine. इसका मतलब है now we have, in addition to the pi and sigma, we have the non-bonding electrons. So we have sigma electrons present, we have pi electrons present in the system, we have non-bonding electrons. इसका मतलब है इसमें जो transition possibility है, इसमें when it absorbs the energy, एक possibility ये कि this transition will occur sigma to sigma star. Second possibility है कि this transition will occur. और possibility arise है कि जो non-bonding electrons है, they can get excited to sigma star or they can excite to pi star. तो हमारे पास ये transitions possible है. Sigma star transition. So there can be four types of transitions which can occur. So depending on which type of molecule is present, उसी हिसाब से there are the transitions. So now, अब इनमें से किसकी ज़्यादा एनर्जी है, किसकी which will require more energy for the excitation. Obviously जो stronger bond है, जो tightly held electrons होंगे, they require more energy. So for that we'll draw a diagram here. तो उसके लिए हम क्या करेंगे, विल ड्रॉ ए डायग्राम. So before we draw the diagram, I can take the example of water understanding के लिए. So water में किस किस्म की transitions possible है. हम जानते हैं कि there are lone pairs present here. ठीक. So ये sigma bonds होते हैं. So it can be n2 sigma star transition, एक possibility ये है. और दूसरी possibility ये है कि it can be sigma to sigma star transitions. तो इस तरह के ट्रांजिशंस हो सकते हैं. सो दीज आर द वेरियस पॉसिबल ट्रांजिशन. तो जिस टाइप के बॉन्ड्स और इलेक्ट्रॉन्स प्रेजेंट है उसी टाइप की ट्रांजिशंस की जो है पॉसिबिलिटी विल एग्जिस्ट. नाउ सो विल ड्रा अ डायग्राम ऑफ सिग्मा. तो हम डायग्राम को ऐसे बनाएंगे, विल शो इट सिग्मा हियर. सो दीज आर द सिग्मा बॉन्डिंग एनर्जी लेवल. So that means corresponding to sigma there will be antibonding level. Antibonding is a higher energy level. So that will be sigma star. So there's sigma bonding and corresponding to that is sigma antibonding. ठीक है, sigma bond सबसे ज़्यादा stronger bond है. That means it is antibonding orbital की भी energy उतनी ज़्यादा होगी. अगर हम scale ऐसे दिखाएंगे, this is a scale which is actually rise in the energy. It was this side where higher energy and this is the lower energy. Now likely if we put pi electrons जो है they are less stable. Pi bond is a weaker bond, that means higher energy. तो pi bonding की भी higher energy होगी than the sigma bonding. तो pi bonding की higher energy होगी. तो sigma bonding की सबसे ज़्यादा least energy followed by pi bonding. तो corresponding pi bond there will be pi star, that is pi antibonding orbital. अब यहाँ देख सकते हैं, ये देखो पाई और पाई बॉन्डिंग की इसमें गैप थोड़ी कम है, लेकिन सिग्मा और सिग्मा भी ज्यादा. जितना सिग्मा बॉन्डिंग ऑर्बिटल जितना ज्यादा स्ट्रांग बॉन्ड है तो एंटी बॉन्डिंग ऑर्बिटल उतना हायर एनर्जी में होगा. लाइकली ये पाई बॉन्डिंग चूंकि वीक बॉन्ड है तो इसकी इट विल बी लेस स्टेबल कंपेयर टू दिस, और उसका एंटी बॉन्डिंग भी इतना क्लोज है, उसकी दरमियान गैप भी लेस है. एंड देन वी हैव द नॉन बॉन्डिंग पेयर. चूंकि ये नॉन बॉन्डिंग इलेक्ट्रॉन्स है तो इनका एंटी बॉन्डिंग तो होगा नहीं. नाउ सो वी कैन स्टार्ट कैलकुलेटिंग द टाइप्स ऑफ ट्रांजिशन. तो एक ट्रांजिशन ऐसे होगा, उसको हम यहां से दिखाएंगे. सो दिस इज वन ट्रांजिशन, इट्स फ्रॉम सिग्मा टू सिग्मा स्टार, सिग्मा टू सिग्मा स्टार. Obviously its energy gap is more, that means इसको ज्यादा एनर्जी चाहिए to excite the sigma electrons from ground state to excited state. Then we have pi to pi star also here. This is another transition which is pi to pi star. Obviously gap is less, so this is pi to pi star transition. Then we have this n to pi star, n to pi star transition, and then we have one more, that is n to sigma star. So this transition थोड़ा टेढ़ा हो रहा है. So this is n to sigma star, n to sigma star transition. So there are these four types of transitions. तो that means अब इनकी अलग अलग एनर्जी होगी. So we'll show the energy order. ये बहुत ही important है, energy order. So the energy order, तो हम ऐसे दिखाएंगे इनको कि सिग्मा टू सिग्मा स्टार यहाँ पे दिखाएंगे. सिग्मा टू सिग्मा स्टार will require greater energy for excitation, followed by n to sigma star, followed by pi to pi star. ये क्वेश्चन बहुत ही इंपॉर्टेंट है एंट्रेंस में भी और किसी भी एग्जामिनेशन में. and obviously followed by n to pi star. ठीक, तो ये इसकी एनर्जी, इसका मतलब है अगर वेवलेंथ देखी जाए तो दिस रिक्वायर लेस, दिस इज लेस वेवलेंथ, so it has a more frequency is required for this transition, followed by this, followed by this, followed by this. Energy means frequency and wavelength is inverse. So if you compare the wavelength, so this will require more wavelength, followed by this, followed by this, followed by this. That means ये जो transitions है n to pi star क्योंकि they require larger wavelength. Larger wavelength it can be, so that will fall the visible region. So ये transitions they will fall the visible regions, और ये transitions they will usually fall in the ultraviolet region. So they will fall in the ultraviolet region. So those transitions which are on the higher energy side like these, they will fall in the ultraviolet region, and those transitions which are on the higher wavelength side, this less energetic side, so they will fall in the visible region. And that is why हम बोलते हैं कि when you have molecules which are conjugated molecules which have extensive pi bonds, extensive pi bonded जो molecules they absorb in the the visible range, क्योंकि इसमें transitions, actually these type of transitions रहते हैं और transitions बहुत easy होते हैं. That's why the molecule becomes colored. So this can be actually understood through the electronic transitions diagram. So this is basically the basics of the electronic transitions which actually occur in the U visible electronic spectroscopy. तो हम ये कहेंगे इसमें जो n to sigma star transition है, ये n to pi star transition, इसको further understand करने के लिए for example n to sigma किस किस में हो सकता है, बहुत important question है. So if we have for example halides, if we have alkyl halides, so for example you have alkyl halide, alkyl group में for example it is CH3. If it is CH3, so now since this is a halogen molecule, fluorine, chlorine, bromine, iodine, so it's a n electrons are there, there's all bonds are sigma bonds, so it can have n to sigma transition. Second thing इसमें sigma bonds सारे हैं, so it can have sigma to sigma star transition. Likely if we want to go n to pi, तो n to pi के लिए we can take example. Yeah, here we can take example of amine also. CH3, NH2. Now, lone pair is present on nitrogen, so we can have n to pi sigma star transition. Likely, if we have molecule like OH, so now we have the lone pairs in the oxygen, all bonds are sigma, so it has n to sigma star transition and sigma to sigma star. इसके बाद अगर हमें पाई का देखना हो, दिस ऑल अबाउट द सिग्मा. ये क्वेश्चंस बहुत ही इंपॉर्टेंट है एग्जाम, कीपिंग एग्जाम कंसिडरेशन इन माइंड. इस तरह से इफ यू हैव मॉलिक्यूल लाइक phenol, now this is a phenol molecule. A phenol molecule has these lone pairs. Since इसमें pi bonds present है, ये भी are sigma bonds, so it can have n to sigma star pi star transition. It can have pi to pi star transition, and then it may have n to sigma star transition because sigma bonds भी present है इसमें. तो हमें देखना हो किस टाइप का मॉलिक्यूल, अगर सारे बॉन्ड्स प्रेजेंट है तो अकॉर्डिंगली द ट्रांजिशन इज प्रेजेंट. उसके बाद there are many factors which actually give the color to the compound. Now color के लिए जो concept है, that is the chromophore and the oxochrome. So now if we talk about the color of the compound, so then we have the chromophore and oxochrome concept. क्योंकि तभी मॉलिक्यूल में वो बिहेवियर आता है, फिजिकल बिहेवियर, कलर when it absorbs these radiations, ultraviolet are visible. So chromophore. So there's a concept called a chromophore which is very closely related to the electronic transitions. जैसे मैंने कहा कि chromophores में usually they have n to pi star transitions or they have pi to pi star transitions. तो chromophores वो fragments होती है molecules which are responsible for color in the molecules. So in that they have extensive pi bonds. For example, benzene, for example, carotene, for example, vitamin B12, okay? So retinol. So they have extensive pi bonds, or they have this N to pi star transitions present, pi to pi star transitions, since they are less energetic transitions. Less frequencies required for their transition, or we can say more higher wavelengths required for their transition. Higher wavelengths means that these molecules will absorb in the visible region, so that can be in the violet, indigo, it can be blue, VIP, it can be green, it can be yellow, it can be orange, it can be red, and sometimes in the near infrared, that's called NIR region, near infrared. So because of these easy transitions, because N to pi star, low energetic transitions, pi to pi transitions, they absorb in this region, hence the molecule looks like colored. For example, this example you have carotene, and the carotene. Likely you have, the retinol, extensive pi bonds are there. 10 bonds, 12 pi bonds, and that extensive pi, and then the concept is that when the molecule becomes extensively conjugated, for example, if you have this type of a system where alternate double bonds, then the flow becomes more easier. That means that it leads further to the absorption in the higher wavelength side. So this concept gives color to the molecules. So this I hope this will discuss the color in the molecules, and then the factors shift to color in the molecules, and that which affect the color, this transition in the molecules. So that inshallah we'll talk on the next class. So till then, this is all about the basics of the electronic transitions which occur in the ultraviolet and visible spectroscopy. So hope this is all for the day, and if you have questions, we can ask later.